Alright, let's get one thing straight. This is a terrible idea. But let's say, for the sake of science and a little bit of chaos, that we somehow manage to grab the International Space Station, drag it out of orbit, and very carefully drop it inside an active volcano. What happens next? Does it melt instantly? Does it explode? Does it somehow survive, against all logic, becoming the world's weirdest hot tub? Let's find out. Step 1. Getting the ISS into a volcano. Before we even talk about what happens inside the volcano, let's take a moment to appreciate the absurdity of just getting the ISS down to Earth in one piece. The International Space Station is massive, about the size of a football field. And right now, it's zipping around Earth at 28,000 kilometers per hour. That's 17,500 miles per hour for my imperial measurement fans. Bringing it down safely isn't like landing a plane. It's like trying to park a flaming, multi-billion-dollar cruise ship after launching it off a cliff. If we don't control its descent, it will burn up on re-entry, much like retired satellites do when they're sent to their fiery demise in the atmosphere. But let's say we manage to strap some parachutes onto it, some very strong parachutes, and lower it gently into the crater of, say, Mount Erebus in Antarctica, one of the world's most active and conveniently located volcanoes. Now, what happens next? Step 2. The ISS meets lava. Lava isn't just hot. It's ridiculously hot. Depending on the volcano, lava temperatures can range from 700 degrees Celsius to 1,300 degrees Celsius, or 1,300 degrees Fahrenheit to 2,400 degrees Fahrenheit. That's hot enough to melt steel like butter on a summer sidewalk. And the ISS? Well, it's mostly made of aluminum with some titanium, Kevlar, and other high-tech materials thrown in. Aluminum melts at 660 degrees Celsius, 1,220 degrees Fahrenheit, which means that the second the ISS touches the lava, it's basically a cheese cube in a frying pan. The outer shell would warp and collapse almost immediately, and in a matter of minutes, most of the station would be completely unrecognizable. But here's where things get really interesting. Step 3. The explosion problem. See, the ISS isn't just a giant metal shell. It's full of pressurized compartments. And what happens when you take highly pressurized tanks of oxygen, nitrogen, and fuel and expose them to extreme heat? Boom! The moment the structural integrity of the station is compromised, you can expect explosions as gases expand and burst out of their containers. Think of it like throwing a bunch of aerosol cans into a bonfire, except these cans are the size of small cars. Some parts of the ISS, like Kevlar shielding, might survive a little longer. Kevlar doesn't melt until about 500 degrees Celsius, 932 degrees Fahrenheit. But let's be honest. In a fight between Kevlar and an active lava lake, we all know who wins. Step 4. Can anything survive? You might be wondering, what about the toughest parts of the ISS? The good news is that some parts of the station might not melt right away. Titanium, for example, has a melting point of 1,668 degrees Celsius, 3,034 degrees Fahrenheit, which is hotter than some lava. So, theoretically, some bits, maybe bolts, brackets, or small structural components, could sink into the lava and stay intact for a while. But even if something does survive the initial melting, it's now floating in a bubbling, churning pit of molten rock. Lava isn't just hot, it moves. And over time, any remaining pieces of the ISS would either 1. Be completely engulfed, disappearing forever. 2. Be ejected in a lava eruption, launched into the air like a piece of space junk returning from the dead. Either way, not great news for our space station. Step 5. Environmental consequences. Beyond the sheer destruction, throwing the ISS into a volcano might also have some unexpected side effects. For one, burning all that metal and synthetic material would release a ton of weird gases and particles into the air. Some of them might be toxic, adding extra pollution to the surrounding atmosphere. And let's not forget the explosive force of dropping a massive object into a lava lake. If the ISS displaced enough lava, we could see mini eruptions or lava flows, potentially causing more chaos than we bargained for. Would it trigger a full-on volcanic eruption? Probably not. But it would certainly not go unnoticed. So what's the final conclusion here? 1. The ISS wouldn't stand a chance inside an active volcano. 2. Most of it would melt instantly, while some parts might explode or even be ejected in an eruption. 3. The environmental impact would be bad, not catastrophic, but definitely not something we want to try. And, most importantly, if you ever find yourself in charge of space station disposal, maybe just stick to the usual burning up in the atmosphere approach. At least that way, you won't have to explain why your billion-dollar science lab just became lava soup. If you enjoyed this wild thought experiment, don't forget to like, subscribe, and hit that notification bell so you don't miss the next deep dive into absurd science. Thanks for watching, and I'll see you next time.